After defining the characteristics for expansion number 1, we can continue to expansion number 2. For example, we'll make expansion number 2 starting year 2017. We can have infill drilling like we did in expansion 1, but for example, we can add water injection to it. Define the main characteristics for the water injection, for example, the rate per well and the void fraction. For example, for these characteristics, we will see what the water injection rate is going to look like, what is going to be the number of wells, injector wells, that are defined by that water injection scheme. We can see the oil rate defined here. We see that we have defined for this expansion number 2 in infill drilling, we have defined a plateau of 40 million barrels per day. So we'll see that the production of expansion number 2 tops at 40 million barrels per day, and then it will start to decline once it reaches the decline of onset as a fraction of the recovery. We can see a number of wells that have been defined by the infill drilling option defined expansion 2, and so on. So we can continue defining up to 4 expansions. So we'll see what the main characteristics for expansion number 3. For example, we have expansion number 3 starting at year 2022 and expansion number 2 in year 2027. So we can click here on all expansions and see what will be the overall production as a function of time from this reservoir for each of these expansions. Once we have defined the production curve for each of the reservoirs, the next step is to define the properties of the GOSPs, the CSP, and the gas plant. So for the GOSP, we will see that the GOSP have different units. It has a separator unit, a compressor unit, a water unit, and a desalter unit. And for each of these units, we can define the capacity for the base up to 3 expansions, the capex and the opex, and the starting year for each of these expansions. So for example, we'll start the base expansion in year 2009 to match the reservoir production. And we can also define a fixed operating cost, which is not related to the amount of oil or hydrocarbons being produced. We continue by defining properties for the CSP, which has a single unit, which is the tank capacity. So we can also define capacity, capex, opex, and a starting year, and a fixed operating cost. We will do the same with the gas plant, which have 4 different units: a gas, a liquid unit, a gas lift, and a sulfur recovery unit, for which we will define again capacity, max capacity, capex, opex, and a starting year. For the NGL plant, we can define the recovery fractions. Basically, we can define the product split. For each gas component, we can define which fraction of that component goes into the ethane, propane, butane, and pentane products. We'll leave the default values for now and continue into defining data for the oil markets. For oil markets, Goman allows you to define up to 5 different markets and a spare market. And for each of these markets, you can define a lower and upper bound. So here by default we don't define any bounds. The API degree of the crude going into that market, the maximum sulfur content of the oil going into the market and the price per barrel of oil going into that market. You can also define spare market, and I don't know if you remember that when we define the general options for the reservoir, we define the priorities for each of these reservoirs to provide hydrocarbon to the spare market. So the spare capacity is modeled as an independent market where you can also define the same amount of the same properties, the lower and upper bounds, the API degree, the maximum sulfur content, and the price for that spare market. In this example, the solution found by Goman will be determined by the market requirements. So since we are not imposing any boundaries, any upper boundaries in the production, Goman will maximize the profit from the two reservoir productions, but note that the constraints going into the markets are that the crude should have an API larger than 30 degrees and a sulfur content that is less than 5%. The price per barrel here is outdated, but we'll leave the default values for sake of time. But remember that the actual price of crude will depend on the price differential that we have defined in the reservoir data. So if the price differential is larger than 0, then the actual price will be the price defined in this value plus the price differential defined for that reservoir. Once we have defined the market parameters, the next step is to define the parameters to start a run. So we'll click here on the eye icon on the toolbar to define the maximum number of iterations and the conversions tolerance for the optimization run. Next, we'll click the R icon on the toolbar to start a run. As we can see, Goman solves this problem in a fraction of in a matter of 2 seconds. And once we finish the run, we can start looking at the results. So we can see results in the oil markets. We right click at an element on the production tree, and we see the options available for plotting. For example, at the oil market level, we can see the stack oil rate, and the values are plotted here in the lower graphic pane. So we can see the oil production to market 1 and the oil production to the spare market. We can go and see different quantities at the at market 1, for example. We can look at gas products. For example, we can see the fuel rate, the different components, the amount of C1 and the amount of C2 that went into fuel consumed by the project. We can look at gas plants. We can look at GOSPs production, CSP productions, oil rate and gas rates, water sources, water processing units, power stations if they are defined, and then finally we can go and look at different values that were produced by the individual reservoirs and all reservoirs. So we can go see the stack oil rate, water rate, gas rate for combined reservoirs, and we can also see at the individual reservoir level. For example, we can select a reservoir and see what's been produced for each expansion. So for example, here we can see the production on each individual expansion from that reservoir. Same thing for the second reservoir in our project. Okay, this concludes our first tutorial on Goman. Thank you very much for listening.